Hello, this is Miss Dean, your friendly neighborhood librarian and media teacher, and today we are talking about computer history. Now, the main thing to remember when we're talking about computers is a computer is something that computes, meaning it figures out a math problem. So we can be computers. Machines can be computers, but in this case, we're talking about mechanical computers, machines created to compute math. So the first tool for human beings to help them do math was the abacus. And this is an ancient tool with beads, usually made out of wood, maybe some clay, and it was invented around 300 to 500 BC. Well, you may ask yourself, how the abacus to our handy dandy smartphones with the use of modern mechanical computers, machines to help us do math. First modern computer is what is called the difference engine. So this is obviously a very large machine, and this machine used gears to help store and compute complex math problems, so really big math problems. And it was run by crank. You can see this person here cranking it to give an example of how it would have worked. So how did you put in the information? With punch cards. A little piece of cardstock had holes in it. Each hole represented something on the gears. You cranked it and it would come out with the math problem solution. So this machine was created by Charles Babbage. Charles Babbage was a 19th century British mathematician. So he invented this to help people compute really large, complex math problems. He also had a colleague named Augusta Ada King Noel, the Countess of Lovelace, better known as Ada Lovelace, and she was also a brilliant mathematician. Well, she figured out how to create these punch cards and use them to compute different math problems. So she is said to be the first computer programmer, because she created a new punch card for the computer to do the difference engine to do a new math problem, to figure out a new math problem. So this difference engine was actually never completed in Charles Babbage's lifetime. But moving on, 1890, the United States is taking the census. The census is where people tell how many people are living, how old they are, so on and so forth. And that's a lot of information because there are a lot of people in the United States. So they needed a machine, a tabulation machine. So it keeps tallies, it keeps track of all this information. And it also used punch cards and gears. The main difference is this one ran on electricity. It was created by a man named Herman Hollerith. Herman Hollerith and his majestic mustache used this machine to help with the 1890 census, and then he created a company called IBM. This company created computers for computing machines for all different type of businesses, schools, so on and so forth. IBM stands for International Business Machines Company. Well, these early machines, because they used gears, you couldn't have the gears for a census machine, like you see right here, to figure out stuff about trains. You just couldn't do it. So they all had to be custom built. So they were very expensive. Only a few companies or people or even colleges had them. Electricity. That is the big game changer. So gears, you can only get them so small. They can only hold so much information. But if you use a code, like binary code, which is made up of ones and zeros to represent different words, numbers, calculations, color, sounds, anything, and you use an electronic vacuum tube, they're basically like light bulbs. They're very similar to light bulbs. So these vacuum tubes would light up, and that would mean 1, and then they would go off, and that would mean 0. So you have all these vacuum tubes together going on, off, representing all these different different numbers and amounts and things like that. And they were much smaller than, oh my goodness, much smaller than gears. And you could do anything with them. You didn't have to have a specially made gear for a machine. You could do anything on any computer because you could get the code to do whatever you wanted. So binary is important because and vacuum tubes. Vacuum tubes are the base. Now, modern electronic computers. These World War II machines, the Colossus in Britain and the ENIAC in America, are the two what are like binary running electronic computers. The Colossus was made in Britain, and like I said, the ENIAC, which stands for Electronic, Numerical, Integer, and Computer, was made in the United States, and they used this to calculate different information for the war effort to figure out how to defeat the Nazis and the Axis powers. Well, another person that wanted to use technology to help to, support America in the war, famous actress named Hedy Lamarr. Like I said, she was an actress, very lovely. She was in many, many films. She's often said to be the Angelina Jolie of her time. Well, not only was she beautiful, she was a brilliant inventor, and she came up with a technology called frequency hopping spread spectrum technology. Now, what that does is it goes through all the different radio frequencies and it scrambles up the message and sends it out so the Nazis can't figure out what we're sending. So she wanted to use this in submarines and torpedoes because torpedoes used radio frequencies to figure out where they were off to. Well, she presented this information. She presented her patent, and a patent is what you figure out the thing and they give you a thing and you're like, this is yours now. So she presented it to the Navy saying, hey, I think this would be really great so the Nazis can't figure out where our torpedoes are coming from. And the Navy was like, yeah, but we can't do it. It's too crazy. We can't do it. And so she was very disheartened, and she decided that her best way to support the U.S. in the war was to raise money for the Army and the Navy and so on and so forth. She actually was not recognized for her brilliant contribution until the 1990s when she was very, very old. Now, what does frequency hopping spread spectrum technology have to do with anything you use right now? Well, do you have an Alexa? Do you have Bluetooth headphones? Do you use Wi-Fi to get your internet? Well, all of those technologies are based on spread spectrum technology. So you have Hedy Lamarr to thank for that. So we're moving past World War II and all these brilliant inventions and their giant room machines. A whole entire room. It's very clunky, very, very not great because, you need a whole room just to figure out what 1 + 1 equals. Well, the vacuum tubes were still kind of clunky, so we now go to a much smaller thing called a transistor. It does the exact same thing that a vacuum tube does, 1, 0, on, off. You can use binary code. It is, however, much smaller. Well, electronic transistors, they get them smaller and smaller and smaller. The more transistors you could get into a certain space, the more powerful your computer would be, the more calculations you could compute. So people were taking, this little space and going, I want to shove all these transistors in this tiny, 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 tiny space. So they would try and cram more and more transistors onto a single chip, and that became what is called the microprocessor. So I have a Lego minifigure here so you can figure out about how big a microprocessor is. So all of these little knobbies on here are transistors. There are hundreds, maybe thousands of transistors on this microprocessor. So you can do hundreds, thousands, maybe even millions of calculations all in a second and figure out all of these amazing things. So you go from giant room-sized computer to a computer that probably fits on your desk. And however, desk-sized computers still weren't used other than maybe at colleges, banks, businesses. Well, there were two different people who wanted to change that. Steve Jobs and Steve Wozniak. They wanted to bring the computer to everybody. So they created what is called the personal computer, because one person, you personally own it. It's not just at the bank. So here is Steve Jobs and here is Steve Wozniak creating their computers. And the first one, personal computer they created, was the Apple I, and it looked like this. Not what you would expect a computer to look like, aka it's made out of wood. So obviously, not what we were expecting. But one of the major breakthroughs that they used was this computer with all of its, microprocessors could be hooked up to a screen. So you, the user, could see what in the world was going on. So after they created the Apple I, they went to the Apple II. And they sold this, they sold millions of them. And it is what you would expect an Apple to look like. It has a monitor, it has a keyboard, it has somewhere to store your memory, all the different applications you've done. So you could have a computer at home and you could go to your neighbor's house and look at their computer and they could come look at your computer, but it was really hard to share information. Now they created portable memory. So floppy disks were the first example of portable memory. So you had this disk inside this hard square plastic and you would put it into this disk drive and it would read whatever information you had on that disk drive. Now, it is called a floppy disk because it is hard plastic, and inside the hard plastic, I've broken it open, there is a disk, and this disk was floppy. It kind of flopped around. But that also meant that it would eventually go, disintegrate, and it would lose its integrity and it wouldn't be able to hold information anymore. So we then went on to the more electronic means, the flash drive, which has a microprocessor and all that kinds of things, so it can have all this information. It's not eventually going to go bad. Hopefully. Portable memory. Now everyone has a computer in their house. Well, not everyone, but most people have a computer in their house and they're doing games, making Word documents, making art. This is someone's face. They have portable memory. It's amazing. So this is what it looked like at the age of the beginning of the portable computer. And now everyone has even handheld computers run by millions of transistors on one microprocessor. And on this, we can play games like ABC, yeah. We can create Word documents. We can create art. Like in the Pokemon Detective Pikachu movie. All of the Pokemon were created using a computer. So I hope you enjoyed our journey into the history of computers, and I will see you later.